Oh yes, welcome back to Joseph Jobs Kaira Chemistry Channel. We are once again here for O-level chemistry, and the topic we are continuing with is electrolysis. This is our third lesson. In our previous lessons, I introduced you to electrolysis. I made the introduction to electrolysis. I also looked at definitions of key terms. I looked at definitions of key terms in electrolysis, where we saw what an electrolyte is. We saw what strong electrolytes are, what weak electrolytes are, what non-electrolytes are. We saw what electrodes are. Under this, we saw the anode by definition. We also saw the cathode. We then saw the definition of electrolysis itself. So we defined electrolysis. In today's lesson, I want us to see the theory of electrolysis. The theory of electrolysis. That's what I want us to get introduced to. So I remember telling you that electrolysis usually occurs if ions are free to move. If the electrolytes are dissolved in water to make the ions free to move. In other words, to get what we call free mobile ions that can move to conduct electricity. So on what theory does electrolysis depend on? Electrolysis depends on a theory I'm yet to explain. So what usually happens is that we dissolve a substance in water. Which substance is the electrolyte? So when a substance is dissolved in water, what usually happens is that a solution is formed. A solution is formed. That is only if this substance is miscible with water. If the substance is miscible with water, so any substance miscible with water, when dissolved in water, a solution gets formed. If that substance conducts electricity in solution, then the solution of that substance is an electrolyte. So the solution is an electrolyte. If the dissolved substance conducts electricity in water, if the dissolved substance conducts electric current or electricity in water. That's what we should know first. Now, when that substance is dissolved in water, let's assume it is sodium chloride dissolved in water to form a solution of sodium chloride. There are ions in the sodium chloride. So those ions are positively charged. There is the sodium ion, which is the cation. There is the chloride ion, which is the anion in sodium chloride. So the oppositely charged ions, which are sodium ions and chloride ions, then start moving freely within the solution. So the oppositely charged ions start to move freely within the solution. Maybe something else that I should mention is that this substance that we have dissolved in water must be not only miscible with water, but should be ionic. it should have some ionic character in it, such that it can form free mobile ions in its solution with water. We are explaining the theory of electrolysis. So the oppositely charged ions start to move freely within the solution. How can I best illustrate this? Look at this diagram. You have your container. In your container, you have water added there. And to the water is dissolved our electrolyte or our ionic compound that's going to conduct electricity. When you dissolve it in water, this is what happens. Okay, look at this. This is what happens. The ions now become free in solution. What I'm demonstrating here are the ions free in solution. So if I have actually, we shall have equal number of cations and anions in this solution. So if this is a cation, if these are our cations, if these are our cations in the solution, then there are also anions, negatively charged ions, which are there in the solution. They are equal in number. The positive charges are equal to the negative charges in number. So we have oppositely charged ions in that solution. So the ions are now free to move. Are now free to what? To move. And for that reason, that's why we usually call them free mobile ions. Okay? So that usually happens before an electric current is applied. So what will happen the moment you apply an electric current? Look at this. I want you to see what's going to happen. So when you have an electric current switched on or connected to the circuit, and the solution of the electrolyte is connected to it, this is what will happen. Remember, in our previous engagements, I showed you the setup of the apparatus we use for electrolysis. I showed you this. So we are here to look at more of it, to see really what happens during electrolysis. Now, remember we have had our ions previously in solution. They are free to move. We are now closing this switch. So I'm saying this is a switch closed. The moment you close that switch, the ions that were free in solution will now try to migrate. Remember, according to this battery here, this is the positive terminal and this is the negative terminal. And the positive terminal is usually connected to the positive terminal, which we usually call the anode. The negative terminal is usually connected to the negative pole, which we usually call the cathode. Remember, these ones are negative and positive depending on the type of cell we are using. They are only positive. The anode is only positive and the cathode is only negative if we are talking of what we call an electrolytic cell. We shall let us see what we call an electrochemical cell, and we shall see that the opposite is true. So what will happen in this case? Now the ions that are free in the solution, look at them. You have the negative ions. You have the negative ions in this solution here. The negative ions in the same solution, you also have the positive ions. You have the positive ions in the same solution. They are all free to move in the solution. So when you close this switch, when you complete the circuit by closing the switch, the ions start to move. The negative ions usually migrate to the anode. They fight for places near the anode. Remember from your physics that unlike charges attract, so these ones tend to migrate to the anode, whereas the positive charges, the positive ions, the cations, try to migrate to the cathode. They migrate to the cathode. So at the end, what do you have? Negative ions migrate to the anode. Those are the anions. Then the positive ions, which are the cations, migrate to the cathode. So at the end, what do you have? At the end, you have something of this kind. You have it that the negatively charged ions are around the anode, and the positively charged ions are around the cathode. So around the cathode, you will have negatively charged. Around the anode, you have negatively charged ions congregating there. So negatively charged ions are attracted to the anode, and then the positively charged ions, which are the cations, are attracted to the positively charged ions are attracted to the cathode. That's the theory on which electrolysis depends. To take you back, we said, first of all, the substance dissolved in water to form an electrolyte. The opposite charged ions start to move freely within the solution. So the ions are now free to move in the solution. So we are now saying that when an electric current is applied, when an electric current is applied, what happens? What happens is that the anions which we are saying are the negatively charged ions. The anions, negatively charged ions, move to the anode. I want you to note this. Anions, anode. Anions, anode. Whereas the cations, in brackets, positively charged ions, positively charged ions move to the cathode. I want you to note this. Cations, cathode. Cations, cathode. That's where they do move. So that's the theory on which electrolysis depends on what we call the theory of electrolysis. Thank you for attending this lesson. Continue to subscribe our lessons for more. Our next lesson about electrolysis will be looking at an experiment. We shall see an experiment to distinguish between strong. We shall be describing that experiment. We shall describe an experiment to distinguish between strong, weak, and non-electrolytes. An experiment to distinguish between strong, weak, and non-electrolytes. See you then and have a good time.